right, here. So last problem on this review for now, before I add some additional problems here, we need to solve, gosh, I did not write instructions here, but of course we are solving here. And I will make sure this is updated on the worksheet. Now we have, notice here, I just want to point something out here. We have log 4, log 3, and we'll tackle that here in just a moment. Typically, when we're solving log problems, we need to either consolidate all the logs on one side, and sometimes it equals, like for instance, we'll find out very shortly that we'll have a series of logs on one side equals a constant, right? But don't take that for granted. Look at everything from left to right. See what you can actually simplify here. Now I will simplify the left-hand side or use what's called condensing log expressions. And we can say, and this just means the rule here, log x, we'll call it, yeah, log AB, log A plus log B. Okay, so I know if I have a product right here, or A times B, I can split it. I can actually go backwards and condense it. That means I need to take log base 4, and I need to take x times x plus 6. Lovely. Okay, now you should notice, now a lot of times you'll just have like log base 4 and then something, right? Whatever. And then once you have, I'll just say A. It doesn't matter because I'm just changing it a little bit. But notice, once you have log 4, you simply drop those and then you solve, you just set these equal to each other and the world is round. But that's not the case here. We're not actually dealing with that particular kind of case here. What we're dealing with is we're going to simply, I'm just going to see if I evaluate that to a simple number. And yes, yeah, our base of 3, we can take that to the second power and get a resulting 9. Now remember, I'm just going to erase this here for room. Log base 3 of 9, what is that equal to? Well, we know 3 to the x power equals 9, and that's, x equals 2. We know 3 times 3 is truly 9, so I'm going to pop a 2 in there. And this is just simply converting our log expression to an exponent expression to evaluate our logs. That's how we evaluate logs in the log world. We know we have a log to a base gives me a number. I call it result. Number is going to give me my exponent, right? And we know in exponents, in the exponent world, we have base to an exponent gives us a result or a number, right? And so we use these setups to convert between the two. So I simply used what I know about logs and switched it over to the exponential. This is our log versus exponential format. And I can say, for my convenience, well, I know log base 3 of 9 is 2. And I'm going to leave it at that. Because now what I can do, I can actually employ converting log structure to exponential structure. I can say 4 to my exponent of 2 equals this. And hopefully your teachers have taught you, you take your base over here on the left, and I'm going to go ahead and just redo it for clarity. Yeah, maybe do it black. Yeah. So my base 4 exponent 2 gives me a result of x times x plus 6. So I'm going to go ahead and write that out. 4 squared equals x times x plus 6. All right, and now we're working in straight algebra land here, where I can say, okay, 16 equals x squared plus 6x. And then I can set my quadratic to 0 and see what I can do, maybe factor it, or quadratic formula, or complete the square, whatever trips your trigger. I'm just simply going to move the 16 over to see what I can get. And I'm running out of room, so I'm sorry about the tight squeeze there. Plus 6x minus 16. Okay, So for room, I'm just going to re-add this over here. And I think this factor is if I put x minus 8, oh, no, x plus 8, x minus 2. Yeah, that gives me x squared. Always check. When in doubt, check. Plus 8x minus 16. That's x squared plus 6x minus 16. Yeah. Okay. So that works. And then we could have two potential answers. I could have x equals -8, x equals 2. However, can't log a negative number. Okay. Because think about it. If I apply an exponent to a number, that result will never be, it shouldn't be negative. It shouldn't give you a negative result. In other words, my exponential, assuming you have a positive base, they're always going to be, it's always above 0. Okay. That's a little, probably more than you need to know or care to remember. But yeah, always look for extraneous solutions. So I can only have a, my x equals positive 2. Yeah, because if I have -8, if it bombs out anywhere, right? So if I plug it in, it's actually going to bomb out on both log. Okay. This, if you take the log base 4 of -2 or log base 4 of -8, your calculator is going to say, nope, sorry, that's an error. And so, yeah, those cannot be done. Extraneous, we just have x equals 2. And when in doubt, you can always go back through, like, just for extra, yeah, log base 4, 2 plus 6, right? Yeah. And then log base 4. And then ultimately, yes, we know log base 3 of 9 is 2. And so I'll have log base 4 of 8 plus log base 4 of 2 plus 2. Okay. And then I end up having log base 4 of 8 times 2, which is log base 4 of 16. Yes, I'm just doing that for clarity here. Yes, I know if I use my, what I know about logarithms and exponential equations, I can just take 4 to the second power equals 16. Yep, you bet. I believe that's true. Yes. All right, so that is the final answer. We have x equals 2 is your answer for this number 10.